This episode is brought to you by Peloton. Break through the busiest time of year with the brand new Peloton Cross Training Tread Plus. Powered by Peloton IQ. With real-time guidance and endless ways to move, you can personalize your workouts and train with confidence, helping you reach your goals in less time. Let yourself run, lift, sculpt, push, and go. Explore the new Peloton Cross Training Tread Plus at onepeloton.com.
Sierra has all the best active and outdoor brands you need. From athletic stuff, like a full court pickup game, swish, to athletic-ish stuff, like a half-mile stroll. Get those steps in. And for morning hikes up the mountain trail, good pace. To nighttime ghost stories from the camping chair. What a twist. Whatever level of active, Sierra loves it all. Head to Sierra or Sierra.com for the brands you want at the prices that let you do it all. From athletic to athletic-ish, Sierra's got it.
The Last Show with David Cooper, where we utilize non-linear reverse, inverse, backward thinking protocols. It sounds like this.
Imagine I told you I could freeze water. Well, if I own a fridge, it's not that impressive. But what if I told you I could do it without a fridge and that I was fungus? Well, there's a form of fungus that can freeze water, and we're here to learn about it here with chemistry professor at Boise State University and at the Max Planck Institute in Germany. His name is Konrad Meister. Konrad, welcome to the show.
Thanks for having me.
So this sounds like total science fiction, like something out of a movie. A fungi, a funguses, I never know how to say that word properly, that can freeze water. What is going on? Paint a picture for me here.
Yeah, I think it's been super unexpected for us as well, because I think the journey started actually being us going to some of these very cold places. In this case, it was in Alaska. And then when you're in Alaska and you see all these lichen, which are basically fungus mixed with some other microbes, you realize that for some reason these lichens can survive freezing super well. And that is, of course, very nice to begin with. But then you want to know, how can they do that? And then we started looking into it. And we really found that there's this fungus that's super good at ice making. And then we poked a bit further, and then we saw it's not only the fungus, is something in the fungus that's so good at ice making. And so then the real bizarre thing was that these fungi that are so good at ice making, you not only found on the ground, but you also seem to find them basically in the clouds and in precipitation. So that really raises the question of what makes it rain and why does this fungus have this capability?
Fungus in the clouds? How do you even discover that? What's going on?
Yeah, that's the weird thing, because we always obviously want to know, why does it rain, and like what causes cloud precipitation, I think is the word, where we make ice in the clouds so that it comes down. And I think the idea is not completely new, because they had found some bacterial, some plant fragments up there, and then sometimes they found these fungal spores. But now we're actually starting to understand why and how good these fungi really are at ice making, because they are pretty exceptional, and they're also pretty much close to being indestructible. So that makes it a really, really interesting product as well.
So ice obviously needs cold temperature to form. What is the trick here? What are the funguses doing to create ice, like in warmer conditions? Yeah,
so, obviously in high school, we all learn hey, if below 0 degrees, it should be ice. Above that, it should be liquid water. But in reality, it's almost like you need, I always say, hey, you're standing on this cliff and you want to jump in the water because it's nice and warm, but someone has to push you because you're afraid. So you need this, what we call a trigger or a nucleator. And the fungus, they produce these proteins that are basically a bit of a mirror image of ice. So they have a pattern that looks almost like ice, just built by a certain biomolecule, like a protein. And so basically on that, it enables the water to really fit very, very nice in this ice-like pattern. And then it makes ice at a very, very warm temperature.
It's sort of like ice is the key and the fungus is providing the keyhole, like a molecular structure so that ice can form?
Exactly. So it's like a molecular structure that's basically, so if you think about water in solution, it's like a chaos. It's like a wild club dancing, everything is completely randomized. But now if we add these fungi proteins, it's almost like I'm forced to dance them more in this old school middle age dancing. So now they're already all very well aligned, because then once they become ice, they're basically stuck in their positions, right? And that's why, for instance, ice floats, right? Because ice is much more structured. And so you basically enable them with this with the structure. You create this patterning effect of this water, and then it basically forces the water to not being let's say a wild disco dancer, but rather to be like in a stuck state.
Why would the fungus want to do this? Like evolutionarily, what's the advantage?
Yeah, that's one big question. And I'm obviously like a chemist, so I don't really know too much about some of the biological questions, but to the colleagues I talk to, and when we start thinking about it, so there's a few things that the fungi might benefit. A, it might actually want this ability to get around, because I mean, we all want to see places. And if the fungus would be trapped in a situation and it basically would be on a host and there's not enough nutrition, how would the fungus get from A to B? And one way could be to actually go all the way in the atmosphere and then rain down somewhere else, and that starts to colonize over there. That's one big thing. The other thing is that these fungi are freeze tolerant. That means at parts of their state, they actually can survive being in a semi-frozen state. And that could be useful, for instance, if you're in very cold places like the Arctic. It's like at some point there's just simply no food and gets too cold that you don't really want to be around. And so I can go almost in this like dormant state. And if I want to be in a dormant state, it's kind of a very nice way to kind of initiate the freezing outside of the fungus and then slowly pull out the water rather than being frozen right away, because then I could damage something that don't want to have to be damaged.
Maybe the fungus isn't thinking on the time scale of humans. It's thinking like, okay, well, there was an ice age, I don't know, 20, 30, 50,000 years ago. There might be another ice age in 100,000 years. I got to survive that.
I mean, that's actually a very good idea, because there's also these stories that we see that, for instance, with the permafrost melting in the Arctic, that there are certain fungi and bacteria trapped that have been frozen for such a long time, and we don't really know what we're gonna get out of those.
Could we use this technology or these funguses to seed the clouds, to control the weather? I know I'm sounding like a conspiracy theorist right now, but is it doable?
It's not only doable, but it's actually something we're actively working on. Because one thing you have to imagine is they're very good at ice making. And currently with seeding the clouds, or companies that are seeding the clouds, they do that with silver iodide, which is a chemical, which is not ideal in many ways, because it's a chemical product versus a biological product. And if you can think about, we don't want to seed with the fungi, but we want to seed it with the active compound out of the fungi. And so that would be a really interesting way to kind of get some form of an environmentally friendly cloud seeding, which I think is a much better idea than using a chemical.
Yeah, currently our thoughts around cloud seeding involve what, toxic chemicals and things like this?
Exactly, that's the current thought. And I think one should also think about sometimes with the cloud seeding, I'm technically not a big fan of saying like, hey, we want to change weather patterns, because let's face it, it's never a good idea to play that. However, if we could prevent, like if you see there's a really dangerous storm coming towards regions and you can seed that storm earlier, so that it's going to go off, let's say, over the ocean rather than over like an important agriculture or ecological part, then I think it's not a bad idea at all. But I personally also still think I'm a scientist. I'm really just curious about, as you said, why the heck would the fungi be so good at ice making?
It seems like everywhere we look, like deep ocean where there's no light, deep in the Earth's crust, like under, I don't know, tons and tons of rocks. It seems like these life forms exist even where we don't think they will. Were you surprised by them existing up in the clouds, this particular fungus?
Yes. And no, maybe, because you're right. I think a lot of times we just imagine, and we've probably heard about these hydrothermal vents too. We go to the bottom of the ocean and there shouldn't supposed to be any life, and it's full of life. And so, yes, like I'm very surprised that we found so much and such a diversity up there.
There is nothing cooler than fungus, and I appreciate you coming on the show and talking about these ice-making fungi. Or is it funguses? I don't know, Conrad.
I actually think no one really knows.
That's the deep question. Conrad Meister is a chemistry professor at Boise State University and at the Max Planck Institute in Germany. Conrad, thanks again for being on the show.
Thanks so much, Dave.
This episode is brought to you by Athletic Brewing Company. No matter how you do game day, on the couch, in the crowd, or manning the snack table, Athletic Brewing fits right in. With a full lineup of non-alcoholic beer styles, you can enjoy bold flavors all game long. No hangovers, no buzz, no subbing out for water in the second half. Stock the fridge for tip-off with a variety of non-alcoholic craft styles available at your local grocery store or online at athleticbrewing.com. Near beer, fit for all times.